Hi guys, well we're at Computex 2016, we're over at the Noctua booth and Jakob's going to be taking us through a number of new products here that they are yet to be releasing. So,
hi everyone, welcome at our booth. I'll briefly introduce you to some of the products and prototypes we have on display here. We'll start with the Chromax line Heatsink covers. At the end of last year we've introduced the colored Chromax pads that allow people to color customize their Noctua industrial PPC fans. And since they have been such a big success, we will now introduce heatsink covers for color coordinating heatsinks to specific build color schemes.
Okay, so are these, I gather these are for your existing products. What type of CPU coolers are they for?
Yes, exactly. We'll start off with versions for the popular NHU12S, NHD15 and NHD15S. And we'll have three different designs to begin with. One all white, one all black, and one black with interchangeable inlays, which will come in red, yellow, white, black, blue, and green.
Nice, very nice. So with these covers kind of covering the top of the heat pipes, and heat sometimes obviously rises through the top of the heat pipes, is that going to have an effect on the temperatures at all, or?
If you have a very, very good setup, you might be able to measure like a 0.1 or 0.2 difference in temperatures. But in all honesty, the difference is going to be very slim because most of the heat that is rising up through the heat pipes will already be transferred to the fin by the time it reaches the very top.
Yeah, so it's marginal.
Yeah, it doesn't really make a difference in real world performance.
Okay. And what were you looking at for ETA on the production? When people can pick these up, and also the price of these?
The price is not fixed yet, so I cannot really say, but we hope to have them done and on the market before the end of the year.
Okay, and we've got this gigantic fan here, so what's this all about?
This is a 20 centimeter fan. This form factor has become more and more common in cases as an intake fan or as a side panel fan. Customers have been asking us for 20 centimeter fans for a while, so we started working on it.
Yeah, I was going to say, because Noctua has obviously got the 120, the 140s, and I wondered how long it would be before we got the bigger one, the 200mm, because obviously those go at the front and also the side panels and things like that. So why has there been such a kind of big gap for the production of such a thing like this?
Yeah. Well, the reason is that it's quite tricky from a manufacturing point of view. We've been working on it for several years now, and we had a prototype on display at last year's Computex already. But the big challenge is that the impeller of such a big fan is so much heavier than what we're used to. So compared to our usual 14 centimeter fans, the rotor of this size is roughly 1/3 heavier. So we have 1/3 more stress on the bearing.
Okay.
And this is something we have to deal with. And this is mostly what we've been working on last year. This is the sample we've shown in 2015. And it uses the usual fiberglass reinforced PBT material that we use for all of our fans. And this is the newest sample, which uses a PP type plastic.
Yeah.
Also fiberglass reinforced, slightly more expensive, but with the big advantage of being around 26% lighter.
Okay.
So we have much less stress on the bearing than with the previous generation. And at the same time, we've made the axis thicker. We usually use a 3mm axis, and this one here has a 4mm. So we can distribute the load over a larger bearing surface, and this way we can finally bring up this big and challenging fan to the longevity standards that we require for a Noctua fan.
Okay. What's the life expectancy on something like that, the bearing in this fan? Do you have that?
All of our fans come with a 150,000 hour plus MTBF specification. So if you don't want to do the math yourself, that translates into roughly 17 years. And we give a full 6 years warranty on the fan. And since we do that, we really have to make double and triple sure that the fan will live up to these standards. And this is why it took us so long to make this big one ready. And we know people are waiting for it impatiently. But if we release a fan, we really need to make sure that it lives up to the Noctua standards.
Yeah, that's great. What about the price and availability on such a thing? When can people expect this?
Yeah, price is not entirely finalized yet, but it's gonna be slightly more expensive than the current 14 centimeter models.
Okay.
And for availability, we're still running long-term tests at the moment. But if these go positively, as we all hope, then we should be able to have it on the market before the end of the year.
Okay, and in the section behind me here, we've got this little kind of educational type section which goes through different materials and structures. So what is this all about here?
Yeah, we wanted to address a topic this year that we haven't been talking about much. Some people have been wondering why most Noctua fans use pretty plain, flat heatsink fins, whereas some competitors use quite advanced looking shapes. And what we wanted to show with this presentation is that we have been working and experimenting with a number of different techniques in order to increase heat transfer rate of cooling fins, but the topic is much more complex than is commonly assumed and suggested. The main problem is that with all kind of structures you use to increase heatsink fin performance, like Vortex generators or devices to restart boundary layers, you always increase airflow resistance or back pressure, as we call it. So it's always a trade-off between these two sides, increasing heat transfer rate on the one hand and keeping the pressure drop as low as possible on the other side. And what makes this whole topic so delicate is that different fin designs can perform different using different fans, using different air speeds. So whereas, for example, fin type A may have a higher heat transfer rate at a low fan speed, it may have a lower heat transfer rate than fin type B at a high fan speed. So with a lot of designs we're looking at, we, for example, see good results at 1500 RPM, but the inverse at, say, 800 RPM. So this is not something we're entirely satisfied with. It involves a lot of fine-tuning to really get good results, and it's extremely tricky to actually get results that are better across the board. And this is the key reason why we haven't been using anything other than plain standard fins so far.
Okay. So it's kind of, you're going for something which is going to be a lot more effective in terms of the performance over anything that is, styling aesthetics, which other brands tend to go for, and cover it up with a bit of marketing blurb.
We wouldn't want to do it just for the looks.
Yeah.
That's not the Noctua way.
No.
So effectively, one of the misconceptions in the whole field comes from the fact that a lot of research that is being done in this field at a university level is done for very high-speed fans. So we're talking about turbo engines and things like that. And very small design measures like vortex generators have hugely different effects at very high air speeds than with very slow-running fans like we use in computers. So a lot of designs that you usually see do nothing at best, or even reduce performance because they create too much resistance for low-speed, quiet cooling fans.
Okay. That's very good. I mean, it obviously proves that you're not in it for the style over substance. So that is great. Well, thanks very much anyway, Jakob, and we'll have more content coming very soon.